So in the last video, we had seen the remainders and cyclicity. Now in this video, we will be talking about factorials and what are the implications of the same. So see, factorial is nothing but the product of all the natural numbers from 1 to that particular number of which we have to find the factorial. And it is denoted by n factorial. It is equal to 1 into 2 into 3 into up to n minus 1 into n. Okay. Now here, this factorial is valid for n belongs to the set of whole numbers. Okay. Now here, why whole numbers? Because 0 factorial is equal to 1. 1 factorial is equal to 1. 2 factorial is equal to 1 to the 2. 3 factorial is equal to 1 to 1 into 2 into 3, which is 6. 4 factorial is 24. 5 factorial is equal to 120. Then 6 factorial is equal to 720. 7 factorial is equal to 5040. And 8 factorial is equal to 5040 into 8, 4320. Zero. 40320. Okay. So these are some of the common factorials that you can keep in your mind. Now, one of the implications of the factorials is the index of the greatest power. Now, what does it mean? See, for example, we have a number 2 to the power 7, 3 to the power 5. Now here, index IGP of 2 is equal to 7. Like the maximum power of 2 is 7. Then IGP of 3 is equal to 5. But what is IGP of 6? So in this case, what we do is we check the exponent of 2 into 3. Now 6 is not a prime number, it is a composite number, which is 2 into 3. Now IGP of 2 is 7 and this is 5. So whichever is lower out of the 2, we consider it as our answer. Okay. Then IGP of 2 cube. Now this is equal to maximum power of 2 cube that can be divided from this number to get a natural number. So IGP of 2 cube is 2. Why? Because for such cases, what we do is 2 to the power 7 divided by 3 and we find the GIF of it. Now this is the GIF, which is the greatest integer function. So GIF is equal to the less than or equal to number inside it. So for example, 7 by 3 is equal to 2.33 bar, right? So the division will yield a number which is 2, the GIF. Okay. So this is all about index of the greatest power. And there are two cases wherein we can find a IGP. So the first one we had already seen, IGP of a divisor in a number for the 2 to the power 7 into 3 to the power 5 example, correct? And I have also shown the cases over there. But what if I can tell you that the second case is IGP of a number P in n factorial. So here, case 1, let us say P is prime, okay? So let us take an example, 2 to the power 8. Okay. So let us say P is equal to 7 and n factorial is 256 factorial. So method 1 is doing the division, 256 divided by 7. We will do the approximate division only. Okay. So 256 by 7. So 7 threes are 21 and 7 six are 42. So 36. Then again a division by 7 will give us 7 5s are 35. So we will get a 5 here. So the IGP of 7 in 256 factorial is equal to 36 plus 5, which is 41. Okay, so you do the summation of these. Now this case is only for the prime numbers. And also the second method is to do the GIF, 256 by 7 plus 256 by 7 square plus 256 by 7 cube plus so on. We move on up till we get a 0. So 256 by 7, the GIF is 36. Okay. 256 by 49. Now 49 into 5 is 245. So GIF is 5. Now 256 divided by 343. GIF equal to 0. And all the other numbers will also be 0 up ahead. So this is equal to 41. Okay. Now, what if I tell you that P is not a prime number? P is a composite number. So for example, we saw the case of P is a prime number. The second case, P is an exponent of a prime number, and third case, P is a composite number, which is not an exponent of a prime. So let us say 256 factorial, and this is n factorial, and P is equal to 2 to the power 4. Okay. So method 1 says that you do 256 divided by 16. So 16 square is 256. So 16 will be the quotient. Then you do another division by 16, you get a 1. So 16 plus 1, which is 17, will be the answer. And the second method is 256 by 2 to the power 4, its GIF, plus 256 by 2 to the power 8 plus 256 by 2 to the power 12, and so on. So both the methods are technically the same. It is just the representation. Okay. So whichever is comfortable for you, you can use it. So 256 by 16. So it is 16 and GIF will also be 16. 256 by 256. It is 1 plus 0 plus so on. So all others will be 0. So answer is 17. So this is how you can solve this. Now what if P is equal to, let us say, 30. Now 30 is equal to 2 into 3 into 5. So what you do is, as seen earlier, you find IGP of individuals. So IGP of 256, 2. So 128, 2, 64, 32, 16, 8, 4, 2, 1. The summation of these will be equal to 255. Okay, so if you will make the summation, it will be 255. So this is 255. Then for 3, 256 by 3. 5 plus 6, 11 plus 2, 13. So not divisible by 3. So 3 8s are 24 and 1 6. 3 5s are 15 by 3. 3 2s are 6 and 3 8s are 24 by 3. 9, 3, 3, 3, 1. Okay. And if you do the summation of this, then you will get 9 plus 3, 12, 12 plus 28, 40, and 1, 41. So 41 plus 85 is equal to 126. And 256 when divided by 5 gives 51, 5, 10, 5, 2. Okay. Then further division not possible. So summation is 63, right? So the lowest of these three will be your answer in case P is a composite number. Okay. So that is pretty much it from this particular video. And in the next video, we will be looking at the base systems.